Hello, Alvin ISD boys and girls. Today we're going to be looking at representing numeric data in a box plot, which is our 6th grade standard of 612A. So how are we going to be learning that today? Well, today we'll be representing numeric data, or data with numbers, in a box plot using measures of central tendency, such as mean, mode, range, things like this that we've learned in a previous lesson. And we're going to be using those measures of central tendency and putting them onto a number line. So by the end of today's lesson, this is our learning target. So this is a question that you should be able to do. So you should be able to take this data set and then represent it on a number line. So let's start with a warm-up. The mean of a set of numbers is 8. What could these numbers possibly be? So I want you to take a moment and pause the video and think of some numbers that would have a mean of 8. When you have a set of numbers, please resume the video. Welcome back. I'm so excited to see all of your solutions. My solution, I decided to have 4 numbers in my data set, which means that the sum of my data, the values, divided by 4 would have to equal 8, which means that my data set sum would need to be 32, so 32 divided by 4 was 8. So the first number I chose was 10, and then 6, which made 16. I included a 4, which made 20, so then my last number needed to be 12, so that my total sum was 32, and 32 divided by 4 gave me 8. So my data set was 4, 6, 10, and 12. All right, we're going to talk about what a box plot is for a second. A box plot is a way to represent numerical data into quartiles. So when you're thinking of a quartile, think of fourths. So if I'm looking at my box plot, I see that I have a dot here, and then another dot, and then a dot that I can place at the line, another one, and then a last one. So I'm seeing that this would be my first quartile, this would be my second quartile, this would be my third quartile, and this would be my fourth. Well, this means that this quartile 1 represents 25% of the data. Quartile 2 is the next 25%. Quartile 3 is another 25%. And then the last quartile represents the final 25%. So if you take a look at this, our box that's in the middle of our box plot actually represents 50% of the data. So the middle 50% of the data. We call box plots a 5-data summary because box plots are comprised of 5 different points. This first point represents our minimum, which is the smallest value in a data set. Our next point is what we call quartile 1, so it's the end of our first quartile. The middle point, which is where our line is through, is our second quartile, which means the end of our second quartile values, but we're actually going to call that the median. That is our middle value. This next point right here is our third quartile. And our last point represents the maximum, which is the greatest point on our box plot. So when I'm transferring values from a data set onto a box plot, the first thing that I want to do is to put them into numerical order from least to greatest. This will help me identify my median, my minimum values, my maximums, as well as the quartile values. The smallest value that I see in my data set is 15. So I will represent that first. And then 20, 35, 40, 60, 75, 80, 85, and then 90. So my minimum value is 15. So I'm going to place that dot halfway in between 10 and 20 above my number line. My maximum value is 90, which I will place above the 90 on the number line. The next point that's going to be fairly easy for me to find is going to be my median, which is the middle number of a data set. So I'm going to break my data into halves. So if I cross off this one, I'll cross off another one on the other end. If I cross off 20, then I'll cross off 85, and so on, to help me figure out visually which number's in the middle. So if 60 represents my middle point, which is my median, I'll plot that there. So now my data is actually separated into a lower half and an upper half. Finding my value for the quartile 1 will be the median of the lower half. So the median is actually the median of the lower half will be between 20 and 35, which is going to be 20 plus 35 divided by 2. So we get 55 divided by 2, which gives us a value of 27.5 for our first quartile. So I'll plot my number of 27.5 in between 20 and 30, but more towards 30. And then now I need to find my third quartile. So my median of the upper half is going to be between 80 and 85, which will be 82.5. So I will plot that number. Now that I have my 5 points for my 5 data summary, I will connect the minimum point to the value of the quartile 1. The box goes from quartile 1 all the way to quartile 3 with a line through the median. And then I'll connect the last part of the box plot from quartile 3 to the maximum. And just to kind of review our shape, center, and spread, I'm seeing that the left end of the box plot is longer than the right side. So this will actually be skewed left. My measure of center would be my median, which was 60. And if I wanted to know the spread, I could find the range, which is the difference between the maximum and the minimum, or I could find the range of the box, which we actually call the interquartile range. So our next example, again, I'm going to order my numbers from least value to greatest value just to help me when I want to put them onto the number line. So I'll start with 2, 6, 8, 10, 13, 15, 16, and then 18. And 19. Can't forget about the last one. So now that I have all my values, my minimum is 2. My maximum would be 19. And then now I want to find my middle value. So my middle value, again, is my median. So if I cross off values from opposite ends of the data set, I will arrive at that median of 13, which separates my data into 2 halves, the lower half and the upper half. To find my median of the first half, which is my value for quartile 1, it is in between 6 and 8, which is a value of 7. And then my quartile 3, which is my median of the upper half, is in between 16 and 18, which gives me a value of 17. Now that I have my 5 data summary, I'm going to plot it on my number line. But I notice that my number line doesn't have numerical values on it right now. So it has to be able to represent all of the values in my data set from the minimum all the way to the maximum. So it needs to start at least a 2. And I'm going to say that I'm going to increase by values of 2 to get to 20. Good. So I'll plot my first point, which is my minimum of 2. My quartile 1, which is 7, so it will fall in between 6 and 8. My median of 13, which falls between 12 and 14. My third quartile value of 17, which falls between 16 and 8. And then my maximum of 19, which falls between 18 and 20. And again, when I want to connect my values, I connect my minimum point to my quartile 1. My box goes from quartile 1 to quartile 3. A line goes through the median, signifying that that is a measure of center. And then the final line connects the points from quartile 3 to my maximum. And again, just like our previous example, if I look at this, the distribution of my graph, the shape of it, it is skewed to the left because the tail on the left-hand side is longer. All right, so now we have arrived at our learning target. At this point, I want you to pause the video, attempt it on your own, and then come back when you're ready to check it. All right, so here's my box plot that I represented using the data set. Our minimum was 5. Our first quartile was 8.5. Our median was 13. Our third quartile was 18.5. And our maximum value was 19. Thanks for learning with us today.